Okay, Math Model Semester 2, Lesson 2.1 is the study of similar triangles, and it happens to be the exact same notes for Geometry Semester 1, Study 2.6, which is also similar triangles. So here's what's important. Similar triangles are triangles that have the same shape, and congruent triangles are triangles that have the same shape, but also the same size. Let's write that down. Okay, and so we're going to use a visual cue. It says complete the Venn diagram, and the sentences below, we're going to write congruent or similar in each blank. So there's our directions. Now, every similar triangle happens to be a congruent triangle. So on these lines here, you're going to put, whoops, that's crooked. All right, so how you can read that is that some similar triangles are congruent, but not all congruent triangles are similar. So let's go ahead on and type up our sentence. It says all congruent triangles are similar, but only some similar triangles are congruent. Let's fill it in. Okay, so keeping it moving. All congruent triangles are similar. Only some similar triangles are congruent. So now it says, in your own words, explain what it means to dilate a triangle. Well, to dilate something is just to make it either bigger or smaller. Think about when you go to the eye doctor and they dilate your eyes. They look in to see any imperfections and they're making it larger. That's all. So it's an enlargement. Dilation can be an enlargement or reduction. All right, now you have it all the way typed up for you. What you see right below that by practice 4, it says reduce the original or the enlargement. I went ahead and put that on the next sheet. So let's go ahead on and look at that. Okay, so this was about as best as I can get it to match up. It said making mental images and using visual cues. We're going to draw the two dilated versions of the triangle below. One's going to be enlarged, which means we're going to make it bigger. And the other one is going to be reduced, meaning that we're going to make it smaller. Here we go. All right, so I went ahead and labeled my points A, B, and C prime. That prime is just the apostrophe that you see here, here, and here. That's my first image that I went ahead and drew. Okay, and now you see my enlarged picture of triangle ABC. I put 2 primes or 2 apostrophes to indicate that that's the second picture that I drew. Okay, so the dilated similarity rule, if you can dilate triangle A so it is congruent to triangle B, then the original triangles A and B are going to be similar. Let's write that down. Okay, in practice, when we use notation and symbol to write the similarity statement, the similarity symbol is what you see right here. It's just a tilde. It's what's at the top part of a congruency symbol. And if triangle ABC is similar to triangle DEF, in notation, we would write it as triangle ABC. And you have your similar sign right there. It's a triangle DEF. And that's what it looks like. Okay, so I went ahead and cut this image because it's important that you be able to see the triangles. Okay, and in the lesson, what they talk about is corresponding angles. And on page 13, excuse me, it's page 13 inside of Apex. You can get a better picture of it. So triangle ABC, which is labeled for you, angle A is given as 39 degrees, angle B is 54, and angle C is 87 degrees. Okay, and that's how it's labeled. Now, if we're talking about corresponding angles, then angle A, which is here, the first letter, is going to correspond to angle D, the first letter of the other triangle. So right here, angle D is 39 degrees. Our middle letter is going to be B, and B is 54 degrees, so it's going to correspond to E. So E is going to be 54 degrees, and then C is going to correspond with F because it's our last letter here. It's going to correspond to F, so that one's going to be 87 degrees. And that's how you would label that: 39 degrees, 54 degrees, and 87 degrees. So what you're going to see is that corresponding angles in similar triangles are going to be congruent. So I'm going to just write that down. They are congruent. They should equal every single time. Okay, so the pattern is each pair of corresponding angles is going to be congruent. And remember, congruent just means that they are going to be equal or have the same measure. That's the symbol for congruent. Similar triangles have congruent corresponding angles. That's going to be our rule, that they have congruent corresponding angles. Okay, and so what you see, I drew in a triangle. If you would just go ahead, sketch that in on your notes so that you'll have it. But this right here comes from page 12 inside of your notes. So there's a picture that looks like that inside of Apex. I believe it's on page 12. And if you can't find it, just let me know and I'll help you. So it says corresponding sides. Corresponding sides in triangles, if they are similar, must be proportional. And so we're going to get to that word in a second. But what we have here, it says in triangle ABC, highlighted right over here. AB, that segment is 16. BC is 20. CA is 12. DE is going to be 8. EF, 10, and FD is 6. So what you see right over here is the ratio of those triangles, ABC to DEF. So what you see is ABC is 2 times bigger than DEF, or you could say that DEF is half the size of triangle ABC, since all of those numbers 8, 6, and 10 is half of 16, 12, and 20. All right, so it says the pattern. The pattern is that corresponding side lengths have equal ratios. They are proportional. See how all of these numbers right here equal the same thing? So since those are equal, then it's proportional. Similar triangles have proportional corresponding sides. Let's type that. So right there, your word should be proportional on that line right there. So in practice, corresponding angles are going to be congruent, but corresponding sides are proportional. Okay, and so yeah, corresponding angles congruent, corresponding sides proportional. If you struggle with that, just let me know because I'm here to help you. Hold on. All right, and now we get to talk about scale factor. The scale factor is just the equal ratio of corresponding side lengths in similar triangles. Okay, I typed it up. So it says how to calculate a scale factor. We want to identify first the corresponding sides, because when you're looking at scale factor, it's always going to be the sides. And I think that's why that's important that we had to write that in. Ooh, I like that it says use the order of vertices in the similarity statement. This right here is going to be very important. And if you don't understand that, just let me know because I'm here to help you. Number 2 says write each pair of corresponding sides as a ratio fraction. 3 says substitute the side lengths for the side names in the fractions. 4 says simplify the fractions. Okay, and that's our 4 steps to calculate the scale factor. And it's going to make sense in a minute because we're going to get to do a practice one. So it says you can use the rules below to decide if a scale factor is reasonable. If A is bigger than B, the scale factor is going to be greater than 1. If A is smaller than B, the scale factor is less than 1. Which kind of makes a little bit of sense because if you go up to the top where our ratio, right up here, where our ratio was 2 to 1, if it was getting bigger, then our ratio was 2. If we go from DEF on over to ABC, then it's getting bigger, multiply everything by 2. But if we go from ABC to DEF, then it's getting smaller, so we multiply everything by a half. So it's less than 1, it's a half. Okay, so the next thing I said we're going to practice, and here's the practice. So we're going to use this problem here, and notice it said a figure is not drawn to scale. So in a triangle, in the triangles below, sides AB correspond to DE, or the triangle similar, and we're going to explain. Let's go for it. Okay, so on your notes, you should be able to see the triangles with the chart together at the same time. It says identify the pair of corresponding sides. So if you look at your triangle, AB corresponds with DE. Okay. BC corresponds with EF. That segment, put a line above it, so segment. CA correspond with FD. Put put a line above it for segment. Okay, AB over DE, because that's your corresponding, we got larger. So AB is 7 and DE is 29. So 7 over 29 is my fraction. BC is 24 and EF was 96. That can be reduced to 1/4. And then CA is 25 over 100, well, 25 over 100 to FD. So that one can be reduced to 1/4. But what you see is, you see how these two both equal 1/4, and this one 7 over 29 does not reduce to 1/4. The ratios are not equal. So as a result, the corresponding sides are not proportional. So the triangles are not similar. In order, since SIMILAR, that's supposed to be, whoops, it's supposed to be an I right there. And then that's an M. Okay, so the triangles are not similar. Now, let's just say that this one right here, AB, I'm going to write it in blue because this is not what's true. But let's just say that this was 7, and 7 times 4 is 28. So 7 over 28 will reduce to 1/4. So if that's the case, if that was the case, that DE equals 28 and that was 1/4, then yes, it will be proportional because the ratios will all equal 1/4. But since this is not true right here, it's not proportional, and it's not proportional only because of this guy right here. Okay, all right. Now, once again, I love you very much. I encourage you to do your practice problems. If you have any questions on your practice problems, just let me know. I am here for you.